Hello and welcome to Game Development, looking at 3D platform movement in Unity. We're going to start with a new project. We'll select a 3D project, project a name, create project.
Okay, first thing I'm going to do is set up my environment. I have a different layout. I've named it, but just so I can show you how I do it, I go by a 2x3 layout. I go to Window, General, and Console. I pin the console to the bottom of the inspector. I pin the project pane to the left of the inspector and the hierarchy above the project pane. I switch the project pane from 2 column to 1 column, minimize the packages, and open up everything else in the assets so I can see what's going on. And I open up the hierarchy. I reposition these things, and then I save that layout appropriately, which leads me to the layout I've got here. So let's get started. I'm going to start by creating a plane. I'm going to go to Game Object, 3D Object, Plane. I'm going to check that it's in the 0, 0, 0 location, and I'm going to extend the scale to a factor of 5 on the X and Z. It doesn't change anything if you change the Y because it's a plane. It doesn't have a Y value so much. The scale factor here, 1 is equivalent to 10 units if you were to insert, say, a cube or a cylinder or I'm going to create an empty game object. This time I'm going to right click in the hierarchy and go create empty. And I'm going to give this a name, player object. I'm going to make sure it is located in 0, 0, 0 for now as well. I'm going to rename the plane, that I created before, I'll call it ground. Come back to player object, I'm going to right click on that and create another empty object inside of it. I'm going to name this container 3P. Now, what I'm doing here is I'm going to create something that's a little bit more convoluted than your standard setup. I could just bang in a capsule and start coding it straight away. What I'm going to do here is create something that will allow me to flip between a third person and a first person view, and will allow a little bit of future proofing that I can put a capsule in now and quite easily swap it out later for some better models. So I'm going to call this one container 3P, and that's going to hold my third person controller elements. And inside that, I'm going to create a 3D capsule for now as my placeholder, and I'll call that my model 3P, my third person model. And also inside the container, not inside the model, I'm going to create an empty. Call this contain camera 3P container. And inside that, I'm going to create a camera. Right click, camera. I'm going to happily leave it as named camera, but I'm going to tag it as main camera. So I'm going to happily leave it named as camera and tag it as main camera. Because I have a main camera for now, I'm going to just deactivate that one. So the main camera is no longer used. It will flip to the next available camera, which is this one. Now I'm going back to, let's see, player object. I'm going to tag this as player. And just because I might want a layer for it later, I'm going to add a new layer in. Let's put it as layer 6. I'm going to call it player. And go back to my player object, and player should be in the list. Allocate, yes, change all children as well, why not? So look at our model. We want the model to be resting on the ground. By default, our model is of size 2, height 2. We might want to change that. I could just do it using the scale. Just bear in mind, if anything gets nested in it later, that'll be scaled too. So the idea here is I wouldn't put anything inside of it. I'd just delete the model 3P and put in my new model as and when I'm ready. If I wanted this to be like 1.8, which is about 6 feet, then I can change this to 0.9 because it's a scale factor. It's 90% of its previous scale factor. I could move its center location then 0.9 as well. So it's resting on the ground. And I'm going to leave that as it is. The camera container is going to be a sort of the pivot point for the camera, because I don't want to use the camera's center location. I'm going to put this around about 2, and then set the camera back on its own axes. So then swapping over to the camera and set it back on the Z to -3. I want to try now a rotation on the X of 10, just so it's pointing down a little bit. Let's go to the project pane and add in some folders. So I'm just going to minimize scenes. On assets, right click, create folder. Let's create one for the environment, and I'm going to try and separate out things up for the environment, or things up for the player, and later things up for the enemy and all that kind of stuff, so that it's easy to package up later and keep things separate. So I'm going to have one for environment, and I'm going to have another one for the player. They both will need a folder inside of them called materials. The player will also need, make sure you put this inside player, not inside materials, a prefabs and a scripts folder. Inside the environment materials, I'm going to create a material for my grass. So I'm going to create material, but I'm just going to call it green because it's not going to look like grass, and it's something that I can look to change later. Once I've got that material, I can put it straight away on the plane as well, and if I'm unhappy with it, I can tweak it as appropriate. Inside the player, I'm going to create two new materials, call them blue and red, and they will be, strangely, blue and red. Blue I'm going to put on the model 3P. The red I'm not going to use just yet. We'll use that for a first person model later. Okay, I want to create a bit of an environment for testing. So let's create some empty, some cube 3D objects. I want to create a few of these. I'm going to call them different things. Call this one platform space 1, because I'm going to have more than one of them, and when you copy and paste these, if you've got a space and a number in brackets, it will continue that pattern. 0.5 should place it directly on the floor because it's got a height of 1, unless I want to change that height. If I want something that I can jump, we can jump onto, I do want to change the height, so I'm just going to change it with the Y value on the scale. 2 is a bit much, we'll go for 1.24. 1 to 1.2, and we'll set its position to 0.6. It's going to be half height for the position if you want it to be resting on the ground. And then we're going to give this a bit more width, a bit more length. So I'm going to go for 2x4. I'm just going to set this somewhere. I'm going to create a duplicate of that by selecting it in hierarchy, pressing Ctrl and D, and that makes a duplicate, and it's named it platform 2 for me. I want to create that at a distance so that we can have a jumping platform. If the first one's at 0, you want to pick a distance that should work right for your jumping. And what you want to do is, when you're practicing your jumping, you want to find out what the distance is of your maximum jump, so that when you're placing platforms, you can work out distances that you want to be available, and shorter ones you're going to think, well, do I need a shorter one? And if you want to make things a little bit longer so people can't make the jump as well. So it's all part of your level design. We're also going to need something that the player can use as a wall. So let's we'll just duplicate one of these. Control D. This time I'll call it wall 1. I'm going to give it more of a height. I'm going to give it less of width. I'll give it a little bit more. I'm going to duplicate this, and if I wanted the opportunity for looking at sort of bouncing between walls, I might need to create a space for you to be able to do that. So again, it's about thinking, well, what kind of distance would I want to be able to bounce from one wall to another. And if you want to have sort of building scaling, you might want to make these much taller so you can look at climbing a building or climbing over an object. And you've got to plan out the sizes of things you want to be able to work on. Now for now, I'm just going to leave these like that, and I want something that we can crawl under. I want to copy this platform again. Call this plank. I'm going to lower this a little bit. It's in line with that. I want something that character should be able to walk under. Now I've got to think how tall this is going to be. If that's 0.6 in height and 0.2, and is that the same? So it's going to be 0.4 in height, which might be a bit too low. I'm actually going to raise it up. I do want this to be the same, to increase it. 0.4. Look at my jumping mechanic and work out whether I can get it to jump on there properly. Okay, got a bit of an environment. I'm going to put the ground next to it. And I'm going to create an empty outside of these and call this environment. And I'm going to drag or highlight firstly using you can use Control to individually select them, or you can use select the top one, Shift, bottom one. I'm going to drag all those inside environment. Got platform 1, platform 2, wall 1, wall 2, a plank, and the ground all under environment, just so I can keep it all together and I can move it all around quite easily. Right, I think it's about time we started to work on a script. So right click on scripts, go to create, and a C# script. I'm going to call this player locomotion. Should point out that I don't put a space in my script names because it's awkward when you have your class names, and I actually don't put spaces in my Unity project names because if you're using GitHub desktop, it forces dashes in wherever the spaces are and it doesn't locate correctly. Now I'm going to need to edit this script and I'm going to need to put it on the player object. So I'm going to edit it first. Okay, making a start. Player locomotion is going to contain all the code for our movement. I'm going to start by, I've entered a new line above the class name. I'm going to say require component, open bracket, type of, open bracket, character controller. And these are encased in square brackets. And what that will do is it will mean that when I put this code into an object, it will check whether it's got a character controller, and if it doesn't have one, it will create one immediately as well. And that actually stops us getting the error later of whether we don't have a character controller available. Before the start, I'm going to create some code. I'm going to delete the comments because I don't like these particular comments. I do like a space between my subroutines, so I'm going to leave that space in. So I'm going to define a character controller, capital C's. I'm going to call it character controller with a lowercase starting with C. Use tab there. So I've got a character controller of type character controller. It's not set to anything yet. I'm going to create two transforms, one called player container and one called camera container, and that is going to be used for our to find the transforms of our camera container, camera 3P container, or the player 3P container. And when we set it up with the first or third person, it's going to be able to swap between the appropriate camera containers, so that we can use the one that's relevant at the moment, at the time. We're going to create some public floats. You could create these as private floats and use serialized field. For now, I'm just going to use them as public. Okay, let me go through a few things here. So I've mentioned the first two, the floats. Speed is going to control the speed of movement, moving around of our character. Jump speed is going to be how high our character jumps. We're more of the force rather than the speed, but hey. Mouse sensitivity will be used to determine how fast we can turn. I want to set this to 2F to start us off with. Gravity will be how much force there is pulling us back down. I suggest getting gravity working first before playing around with the jump speed, because you want the falling mechanic to feel right. You don't want to float down, and once you've got the falling mechanic right, you can then move towards getting the jump appropriate to balance the gravity. I'm using a look up clamp and a look down clamp so that when we're looking up and down, we can't look directly up or directly down, and that's actually to do with this setup, how our camera will go into the floor if we look directly up, because of how far back it's set, and I don't want that to happen. Now there are better mechanics to have it not go into the floor, have it basically go a little bit closer to the player as you're looking around, but it's not something that it's in the scope of this tutorial, so it's for now we're going to clamp our look We're going to have move direction as a vector 3, which is going to be our x, y, and z movement amount. So how much we're going to move along the x, y, and z. And we're going to have two floats, one for rotate x and one for rotate y, which is going to help control how much we're going to turn left and right or look up and down. That's what we've set up. Just a quick note, so publics are available in the inspector and are otherwise available outside of this class. Other classes can refer to them. Private vector 3 here, move direction, cannot be accessed from outside the class, and because it's not serialized, will not be visible in the inspector. This float, or these floats for rotate x, rotate y, are effectively private, and by all means I could write private in here. I just went for the option of showing how, whether you include private or not, they are private. So I can choose to write it in, or I can choose to leave them out, and in any event they are private. I don't actually have to set move direction to vector 3 0. What that does is forces it to be a 0 0 0 vector. I don't need to do that because it will be defaulted to 0 0 0. Again, I'm doing that more as a demonstration of what you can achieve. Right, let's look at our start subroutine. Let's remove one of the spaces. There's like one clean break between voids. So our void subroutine, so a void does not return a value. Start and update are standard. Start runs once when the game object is created. Awake is another subroutine that runs once when the game object is created but runs before start. You can look up in the documentation to look at the differences. We're going to make our cursor invisible because nothing worse than having your cursor get in the way. Okay. When you press play and you click on the game screen, your cursor will go invisible, and you won't be able to see it. Press stop, press escape, and your cursor will come visible again, and you can press stop on the Unity if required. The character controller is now being set in the start so that it's going to get the component character controller. Now, if there isn't one, this would create a compile error. So we will actually, compile error is detected before we press play. So this should be detected. Oh, sorry, let me rephrase that. A compile error will be detected before the game plays. So if you press play, it won't play because there's a compile error. Whereas if we didn't have that, we could get this as a runtime error where it just says I can't find the component. I'm going to later create a set current camera subroutine. For now, I haven't created it, and I'm not creating it just yet, so I'm just going to put that in there now as a comment, so no code will run, and later we can remove the comments there, the double forward slashes, so that we can have that as code. Let's go down to the update. I could put all my code in the update that I want, but it's better to break things up into subroutines. So I'm going to create a subroutine. Before I create it, I'm going to call it. And it's not going to like me creating something that doesn't exist. Or calling something that doesn't exist. It's going to create an error on that. I'm going to call it locomotion. If you decided to call your class locomotion instead of player locomotion, you won't be able to have the same name. So just be aware of that. So underneath the void update, I'm going to create a void locomotion. Once it's created, being called in the update now is no longer a problem. We're going to create an if statement that says if the character controller is grounded. Now, character controllers have a Boolean is grounded property, and I could say here when we're grounded, we're going to set the y-axis to 0. So now, notice I've just said if the character controller is grounded, and I've not done any comparators such as double equals true. I could do that, and that is basically what I'm evaluating. However, I can leave off the double equals true with booleans and just evaluate it as it is, and that will do the same thing as if true. If I wanted to do equals false, obviously I could do that too. But if I wanted to check false, I couldn't. That statement there is looking at whether it's true. Oops. You can also do is not equal to true, which obviously is the same as comparing against if it equals false. And not equals true is using the exclamation mark. Now, if I wanted to rewrite this without doing equals false, but I wanted to check whether it's false, I can use an exclamation mark at the front, and that will say basically if it's not true. So there are various options. I am, however, looking whether it is true, and if it is true, So we're going to use our move direction vector 3 that we created before, and we're going to insert into it a new vector 3. We're defining a new vector 3 and we're passing in an x value of input get axis horizontal. And we're passing a y value of 0 and a z value of vertical, get axis vertical. Make sure you spell these correctly, horizontal and vertical, with capitals included, because it will not pick up if you spell them wrong as a compile error. You'll get them as runtime errors, which means you'll get them when you press play. When it runs this script, you'll get a little error saying it can't find that axis and you need to create it. These can be found if I go to Edit, Project Settings, Input Manager, expand open the axes. You see I've got horizontal and vertical listed. Actually, I've got them twice. The first one, horizontal, is allocated to left and right keys or the A and D keys. The second one will be the joystick controls, effectively. You can see it down here, it's on the joystick axes. Same with the vertical, that's on the joystick axes on the bottom, and the first one is on up and down, or S and W. So we can use horizontal and vertical that are mapped to W, S and D, or the arrow keys, or a joystick if you've got one plugged in. And so that's what we're looking for. We're looking for these axes. There is a newer input manager, but these are still defaulted in Unity projects. So we are getting a value from our A and D to sidestep left and right on our x-axes, and a value of W and S for forward and backward on our z-axes. Positive values will move you right or forwards, and negative values will move you left or backwards, respectively. I'm then going to set the transform direction from local to world space, global space. And when I hover over that, you can see the IntelliSense says transforms direction from local space to world space. So that's something we need to do. And then I multiply our move direction vector by our speed. So it's a multiply equal. So it's multiplying itself by speed. Our speed at the minute is 6f. And what that does is it'll multiply our x by 6, our y by 6, which shouldn't change it, and our z by 6. I could map all this into one line, but it's or these two into one line, but I've chosen to break it up. I'm going to come back and add in jumping and crouching soon, but I'll just paste that comment in there to remind me where to come to. Outside the if statement, but still within the subroutine. Consider where the braces are ending here for this. I'm going to start by being affected by gravity, or affecting our character by gravity regardless. So our character's move direction .y. Now move direction isn't being applied to anything yet, it's just a blank vector 3 that we created, so it's not being used for anything yet. But before I implement our move direction, I want to make sure we factor in the y. So it's currently 0, and we're going to set it to something else. We're going to go to minus equals gravity times time dot delta time. And time dot delta time allows for us to factor in the differences between each frame, so that we're not dependent upon frame rate. It looks at the time difference between each frame so that it'd be consistent regardless of frame rate. What this will do then, when we implement move direction on our character controller, is our Y value will push the character down into the ground, and obviously if there's colliders, it should just stay on the ground. Let's implement our move direction on our character controller. So we're going to use the move. There is a simple move option which has its own gravity applied, I believe, and we're going to pass into it our move direction vector, and we're going to multiply that by time.delta time to factor in again the differences between frame rate. I appreciate it looks like we've done that twice. Well, we have done it twice, and it is necessary. Save this. Come back to our player object. I'm going to drag the script in and have a look at how the components change in the inspector. There's our locomotion script. There's our variable speed, jump speed, mouse sensitivity, gravity, look up clamp and look down clamp. but it also created a character controller. It realized we didn't have one, and because we had the require component at the top, it's inserted one for us. There is potentially a problem with it though, and if I zoom in here, you can see a faint capsule-like collider that is in the ground, and that's because it doesn't know there's this model inside. It's just gone for the default capsule collider it has attached to it, and we're going to need to center that. Actually going to need to change the height of it as well. If I just put that into 1, it should be higher than the object that we've got because we changed the height. So we want the height to be 1.8 and we want the y value to be 0.9, and that should now map into the same height and space as our model. It has a slope limit. That's basically the degrees at which it can climb an incline. So a ramp up to 45 degrees it will walk up. Anything higher than 45 degrees it won't. Step offset is how high an object can be that for it to consider as a step that it can continue to walk along. Although I would argue that it's a bit glitches you straight to each surface, so it doesn't look great out the box. And then we've got some well, the factors in mostly to do with how big it is. We can look at those later if we need to edit them. Let's press play. Clicking on my game screen, my mouse disappears, and I can use WASD to move, but I'm not rotating. I'm fixed rotation of which direction I'm facing. That's left, right, forwards, backwards. I do walk into the objects, which is useful to know. So I can't walk through walls. I can, however, fall off the edge. Press escape. I can see my mouse. Let's stop. Let's add in our rotate and throw in some jump and crouch. I'm going to create a new subroutine underneath the locomotion. So I'm looking for the end of the locomotion, not the end of the class, or before the end of the class. And I'm going to type in void rotate and look. We had a rotate x variable. I'm going to use this to get input, get axes. This time we're going to use mouse x. Note the capital letters and the use of spacing between mouse and x. They are, again, it's how it's written in Unity. Let's multiply this by our mouse sensitivity so we can change how sensitive it is. By default, I've set mouse sensitivity to 2. Let's do the same for y with some subtle changes. Firstly, it needs to look for mouse y. And secondly, we need to invert it. That means we need to subtract this value. If you do minus equals this input, it'll make it a negative, or negatives a positive. And we just need to invert it because otherwise moving your mouse down won't look down, it'll look up and it'll not feel right. Now for moving left and right, turning left and right, we can do a transform. Dot rotate. Pass in 0f for our x, our rotate x for our y, and our 0f for our z. That will rotate around the player object that we created. So the player object central location, that's what we're going to rotate around, and I'm happy for that. I want it to be the player that turns, not so much the camera at this point. However, looking up and down, I don't want to move the player up and down. I want to move the container that holds the camera. That means it allows me to use the container rather than the camera's center of origin, center point. So subtly different for this, we're going to use camera container. Apologies, we're not. Before we do that, let's clamp our y value. Rotate y equals math f dot clamp. We're going to pass in the value that we want to clamp, which is rotate y again. And we want to say we want to clamp it by the look up clamp. We want to clamp it by the look down clamp. So that's a minimum and then maximum. First look up and then look down. And that means that you can't just keep moving the mouse to look up higher and higher and higher. We'll get to a point where it just goes, nope, that's as far as you can look. So now we'll factor this in So we're looking at the camera container this time and its transform. I didn't have to mention which transform here, it would just be the transform of whatever this is attached to, which again is the player object. Now we're going to do it with the camera container, which we haven't set yet, so we need to set that as well. We're going to affect its local rotation, and we're going to have it equal the rotate value on the X. The X allows you, if you rotate along the X, it's the up and down rotation for looking around. If we rotate on the Y, it's the left and right. And if we rotate on the Z, it would be like a roll, like if you imagine a flight game, it'd be rolling. To action this script, we're going to call it an update. After locomotion, we're going to do our rotate and look. Like I said before, in the start, I create this set current camera. We're going to create that subroutine now. So I'm uncommenting it out. It's an error at the minute because it doesn't exist. I want to put this after the update, but for the locomotion subroutine. So make sure, again, you're between subroutines in the class. Void, pass in our set current camera, get rid of the semicolon, and there's our subroutine. I'm going to set it in start. So when start runs, we'll set this up. We're going to have to edit this later. I'm going to just set player container to equal game object. So we're going to firstly get the player container, which is going to look for container 3P. It's going to look for it in this game object, and this game object is a player object. And once it's found container 3P, within that it's going to find the camera container called camera 3P container. So these names here have to match up to what's in Unity. Here's our player object. Within that we've got just the container 3P we're going to look for first, and then within that we're going to look for the camera 3P container, so that we'll have both the container 3P and the camera 3P container available to us, though we're really focusing on just using that camera 3P container at this point in time. If I press play, I can look up, but only so far. Again, if I would look up any further, my camera would probably end up in the ground, but you can play around with the settings until you're happy with it. Down, look a lot further down, and I can move left, right, I can move forwards. I can't jump yet, but that's something to work on next. Press escape, press stop. So down to our locomotion, we had this comment where we said we're going to put our jumping and crouching. Let's delete that comment and start with an if statement. We're going to look for an input get button jump. Look for the jump button being pressed. Jump is pre-built into those list of inputs in the input manager in Unity. So again, make sure you've got capital J, make sure you spell it correctly. If the jump button is pressed, we're going to set our move direction on the y-axis to be our jump speed. Note, we can only jump when we are grounded, because I've put it inside the is grounded if statement. So this is nested. So effectively we're looking for is grounded and jump button is pressed. Once we've applied the jump, gravity will also be factored in straight away, and the gravity will continue to be applied after we've pressed the jump button. A separate if statement, so this can run as well as the jump, but again requires us to be grounded. This is to show that as well as using the get button and get axes that we've looked at already, we can also use get key and hard code a key in here. Not necessarily ideal, because it's better to create a system whereby you can probably customize the keys, but for now I'm going to hard code this in. Again, the setup here is not ideal. I'm just trying to get this working for the purposes of what we're looking at. Nothing's going to change in appearance in our character, but I'm going to change the character controller's collider so that it can fit underneath our plank that we made, which, if I recall, had it as a height of around about 1.2. So we're going to change the height and the centering of our character controller, and hopefully this value will give us a number that we can use to fit underneath it. If not, we'll have to check it out afterwards. I have a feeling it might be a bit too high. We have an else. We could do an else if. I'm not going to do an else if. I'm going to comment out the if element. We'd be saying if input dot get key up key code dot c. That's effectively what I'm wanting to evaluate here, but simply if they haven't pressed C, then this can be true and can activate. These should be the settings of whether you've defaulted it to in the inspector first and foremost. You could again code this so that it determines what it is on start and then returns it to the original values, and that might be a better way of doing it in truth. And then you don't have to hard code in these values in it. If you change them in the inspector, you can have the code pick that up and reflect it appropriately. In a similar way, you could probably do something with height where maybe halves it. So again, something to consider. Spacebar makes me jump. I can jump quite high. Again, I might want to play around with that. I don't like how fast I fall. I feel it's a bit slow. I can probably jump on top of these. No, not quite. I can't walk through this, but if I hold in C and then move forwards, I can get underneath. I'm going to click on my player object for a moment. Zoom in on this. Try and have a look at what happens when I press C. You can see that my collider there, which you can see is sufficiently below the bar there. And again, I can play around with the settings to get it close to what I want. It's not in the ground, the character controller, and that's what I wanted to make sure of. While it's playing, you can play around with the radius and the height here. You'll notice they do change. It does change those values when I press C and when I let go. So you can play around with the settings without pressing C while it's playing, and then when you press stop, those values will revert to what they were. Demonstration. Pressing stop. Let's set up our option to switch perspectives as well. For ease, actually, I'm going to highlight container 3P, model 3P, camera 3P container, and camera, and I'm going to simply right click and duplicate. And then we want to rename these ones. I'm going to hide the 3P for a moment. And make sure that with the 1P I can drag in the red. Move over the 1P. There we go, so it's red. Put my 3P back in play. There we go. You don't always see the red or the blue. You only see one of them because they're the same size and shape and everything. But we're going to hide one of these. We'll hide the camera associated with it and the model associated with it. And this is important because if you were to make a multiplayer game in particular, but to be fair, even just for a single player game, your first person model is likely to be arms and a gun. It might not be the full body. It might include legs, you most likely will not include a head because you'll never see the head, and actually it'll get in the way when the head is animating. If the camera ends up outside the head, you'll see your own head and it just won't look right. Typically your model is like arms and a weapon. In third person mode, you then would swap it out for the actual model of the player, so we can swap between those models, and so they are effectively different models, and that's why I've set them up this way, where they're both cylinders of the same size and shape, but one of them will be red and one will be blue, and we can swap them out appropriately. For the purpose of what we're doing, because there's not lots of parts, the camera will be perfectly inside the first person model as well, so you'll never have that issue of camera jerking back and seeing yourself. Well, hopefully not anyway. Let's create a new script. Okay, I've got a lot going on in this one. It's called Switch Perspective. We are going to need the start, but not the update. So I'm going to delete the update and leave a bit of space for writing some muscle routines. I'll get rid of the comment because I don't feel it's necessary. And right at the top here, where I was, I'm going to start with a public enum, which is an enumerator called Perspective. And it basically allows us to, it's like almost setting your own data type where you code in what the options are available. Our options are first and third. Notice I use a comma to separate each one out, but I don't end on a comma or end on a full stop or anything like that. I should put a semicolon at the end of the enum expression as well, at the end of the brace. I'm going to create another enum enumerator. This is our container name, and it's easier for us to later switch between the container 1P and container 3P. And these are the names that, again, are allocated out in Unity. So whatever name you've allocated in Unity, this should replicate that, including case sensitivity. Again, don't forget the little semicolon at the end of the brace there. We want to create a private, although I've not written private, because if I don't leave it, put it in there, it's assumed to be private. Perspective instance. I'm calling it perspective. It's the lowercase. And I'm going to set it to be perspective.third, and obviously I've got the option of first or third, and if you put the dot in, IntelliSense will give you those options available. I'm serializing the field so it will show up as well in the inspector. Let's skip the start subroutine at the moment and create some subroutines. Let's create a void. Let's initialize our containers with an initialize containers subroutine. However, back up here, after our perspective field, we're going to create a couple of groupings. Dictionaries we're going to use. We won't have two of these. The first is a dictionary called container name by perspective. We're going to be able to look up the perspective and find the container name. The second is container by name. So the first one we're looking up the container name, and using that container name we can then look up the actual transform of the container. We need to be able to do both. Firstly, based on the perspective, find the container name, then using the container name, find the transform associated with that name. You need to instantiate these as new dictionaries using the same data types as set up. Don't forget the open close bracket semicolon at the end. Moving back down to our initialized containers now. So in the first dictionary, they're very short dictionaries, we've got 2 items in. Then we're going to add the perspective first and associate with perspective first the container name container 1p. And with perspective third, we're going to associate the name container 3p. We could actually do this in a little different way where we maybe just use text and things, but it is what it is. I've then got container by name, and I'm adding to this the 1p and 3p options. And for each of these, I'm then going to find the game object with that name. We have to use a toString method because we have to turn this into a string. And it should return that game object as long as it exists, as long as all the namings are correct. This is something that we can now use. These dictionaries are something we can now use. Let's create a subroutine called disable all containers. We're going to use this to just deactivate all the containers before we then activate the containers that we need. So our dictionary, each item in the dictionary is a key value pair. Looking at the second dictionary, each item is a key value pair of type container name with transforms. Every transform is associated with a container name. We're going to go through all the key value pairs in our container by name, our second dictionary there. And each time we go through, we're going to consider one pair to be called simply a container. Going through every container in container by name. We're going to look up the value component. So these are key value pairs. The first item, the container name, is a key. The second item is the value, and I can grab either. For this, we're grabbing the value, so the transform. And we're going to do the transform.gameObject.setActive equals false. Set it to false, which will deactivate those game objects. And it's going through both of them, so we should basically deactivate both our container 1p and container 3p. This won't run yet because we haven't done anything to make it run. We haven't called it. We're going to create another subroutine called activate perspective, and we're going to pass into it a perspective. Every perspective we pass in, which is of type perspective, so we've got those options of first or third, is going to determine what happens. So it's going to, first we need to define a container for our container name, so we're going to need to use that. It's going to look up in the container name by perspective, and it's going to try and get a value from the key value pairs, passing in the perspective we've got. It's going to look up the perspective, the key, and it's going to pass out, if it can, a container. Well, a container name, which we're calling container. So again, this is the idea of the first one here, container name by perspective. It has a perspective, and it's either going to be first or third, and it has a container either 1p or 3p respectively. So that's what we're hoping to pass out. If it can't get that, so it's a try, and this works similar with try catch and things. If it can't, or try pass, if it can't get the value, then this will return false, and the if statement won't run. If it can get a value, it will return true. So that's what the try value does. It returns a value of true or false. As well as doing that, we've got this keyword out, which you can use with these try type methods. That will output the result of the try get value, so the value element, and it'll output it in this variable which we created beforehand. We can actually create it there, like this, instead of using that line there. But I prefer to call it beforehand. Right. If it works and we get a container, then we can do our container by name now. And again, we're going to do a try to get the value, this time passing in the container. Now the container, looking up here, is either going to be 1p, container 1p or container 3p. And it'll have looked that up based on the perspective that we've got. And if it can find it, this will return true. And it will output, and this is where I've defined a value here. We've created a variable called transform inline of transform type. It'll output that. If it can't find it, it'll be false, and it won't output anything. Now, assuming it's found it, output it. We can now affect that transform, get the game object, and set its active to true. Quite complicated, I know, but this is what we're trying to achieve. So we've got the option of disabling all containers and activating a single container if we can pass in a perspective. Let's set a function that will return a perspective type. We're going to need this to be public because I want to be able to access it from the player locomotion script. We're going to call it get perspective, and it's going to return the perspective type. And I'm simply going to have it return perspective. Perspective set. Yeah. It's defaulted to perspective third, so unless it is changed, it's going to return perspective third. At the same time, let's be able to set the perspective publicly. This will be a void because it won't return a value. We do, however, need to be able to pass something in. So if we pass in a perspective, which we'll call perspective with lowercase p, we want to be able to set our perspective. Now, we've got two perspectives. The local perspective, this one here that we've created, and the classes perspective, this one. Notice one's white and one's blue. If I use the keyword this dot, it will force it to look at the perspective that's attached to the class. If I don't put that in, it will assume it's the perspective that's local to this subroutine only, that can only be accessed from this subroutine. And it's okay to have the same name, as long as we know what we're doing. And so we can say this dot perspective should equal that perspective. But before we do, we can actually just ask the question firstly, do they equal the same? If they are the same, we'll just simply return this subroutine, which doesn't return any value, it just stops. And that means we can stop activating a perspective if we don't want to. But if it's not the same, and we don't need an else for this, we can just put this underneath. Of course, we've got the return. If it is true, that will return and it won't run. And already it's actually telling us, is this what you want? This dot perspective equals perspective? Yeah, that's exactly what I want. So I'm just going to press tab to accept. I want to do one more thing. That's set the value, but I want to actually switch perspective. I can't call the subroutine switch perspective because that's the name of the class. So I'm going to certainly change it and call it perspective switch. I want to put it before get perspective. It can go at the bottom, but That's where I want to put it. I want to pass in a perspective. Apologies, I forgot to call this a void. A void perspective switch, passing in the perspective, and what we want to do is disable all containers. I'll go through our first person and third person containers, and if we had any others, get rid of those as well. Once we've disabled them, we want to activate just this one container that we want to work with. And whichever perspective we pass into perspective switch, we'll pass into activate perspective. So if we're passing in first, we'll activate the first person perspective. If we're passing third, we'll activate the third person's perspective. We'll go back down now to where we left off, down at the bottom here. Whenever we set the perspective, we want to switch perspective. So let's call our new subroutine switch. Oh, hang on, perspective switch. Not to be confused with switch perspective, which is the name of the class. That's confusing, isn't it? And we're going to pass that straight in. It doesn't matter which one we pass in. We can pass in either of these perspectives. They should be the same. So I'm just going to do that. We're not running this if they're already the same. And that just avoids us having to deactivate all the containers and reactivate them when it's not necessary. This should be the end of switch perspective. I appreciate that was a long one. Now start. We didn't enter these in, so we need to initialize containers. We'll set up our dictionaries and disable. No, we don't need to disable actually. Sorry, we can go to perspective switch and pass in the perspective, which is defaulted to third, and I could change that to first if I prefer. So I'll pass in third as a default. Again, this is the value that we effectively can change from the drop-down list, and it only gives us the options of whatever's in this list here. When I do the perspective switch, it'll disable all containers and set the active perspective. So that's what I was missing. Save that. Let's go back to player locomotion. Let's add in the ability to switch between perspectives. Let's first start by making a subroutine that will check what perspective we're in, determine what to do. I will do this as a void. Just put this at the bottom underneath rotate and look, but still within the class. Now, I don't really need to do this ability to switch between perspectives using the tab. I could just have it so it can be hard set in from a drop-down list, which I'll show you shortly in Unity, and just be able to select it from within Unity. But having the ability to change perspective in gaming might be something you want. And again, hard coding in the key probably isn't ideal, but again, just to demonstrate this straight out back here. So switch perspective is a class that exists, so it'll be recognized. Let's define a switch perspective. Just going to get the component of switch perspective, which should be attached to this player object, where now it currently isn't. So when I add this in, I should make sure I've got a switch perspective added as well. Let's check that it's not null. So let's check it's found a component. If it is null, this won't do anything. If it isn't null and has found a get component, the component of type switch perspective, let's do something with it. We're going to run get perspective, which is a subroutine. We created a function that will return a type of perspective. Now we want to use the enumerator for perspective to look at with our options, which were first or third. But we don't have that enumerator as part of this class, so we have to actually go into the switch perspective class and ask for a perspective.first. We're comparing, is our perspective that we get the same as first? And if it is, let's run the set perspective inside switch perspective to set our perspective to third. And again, we have to look at find the enumerator within switch perspective. Now we notice the differences here that we're using the class of switch perspective without having an instance of it here, just to get the enumerator options. But I have to set it the instance of it because I want an instance, as to say that one of these has been created. We want to affect that so that we can refer back to it, so when I change a perspective, I can go in and check that it's been changed and all that kind of stuff. It's updating it. We need an else in here. And this is saying now that, so if we were set to first, we're going to set it to third. If we're not set to first, We don't need an else if for this, we're just going to set straight to first instead. So it's going to alternate between third and first. Now if we add in other perspectives, you'll need else if statements in here. Outside of this if else statement, but still within the nested if statement here, that's checking for the null. We're going to set our current camera. Now, set current camera, we're going to have to tweak. It was forced to just find the third person cameras or camera container, and now I want to have a bit of an option. So before that code, let's start with, again, our switch perspective. We want to create an instance of it. Now there's an argument to say that really we could define switch perspective up top, under here somewhere, within the class. Use the get component within the start, and then we can use it across subroutines, and I'm not against that. Similar to what we had before, we're going to look at the perspective that's currently set in here, and if it equals first, we can set these values, copy those, paste them in here, to 1p, and if they're not, we'll then run with the 3p that we already have. I need to call that. Now, we're going to have to check every update, every frame, see if that tab button's being pressed. So, a lot more convoluted adding this idea of switching perspective. We've got that new class that we've created. And we're going to use that class, but what we haven't done yet is actually pass that into our object. So let's do that. Player object. We could use get component switch perspective in our player locomotion as well, so that it forces one in. Switch perspective, let's drag that in, there we go. Now this is what I wanted to show, that you've got this third drop down, and you can switch between first and third. Because perspective is of type perspective, and that is an enumerator where we had those two options, it forces the developer to choose between these two. So you can have that without even using the tab key change. Now if I just press play, I want to check everything works. Now I've set it back to third. I want to see that the first or 1p containers are deactivated. Yes, they went deactivated. We have started in first person. I press tab and it goes to third person. So I can now tab between them. You can see it changes in the game view, the scene view, sorry, it changes between red and blue as well. So we can see the different models, and you can see in the hierarchy how it's deactivating and reactivating containers. It's actually deactivating all containers and reactivating just the one we want. And I should be able to flip between them even mid-air. Okay. That concludes the player movement. And what I'd recommend you then do is export these as packages. Let's create a prefab of the player first. I'm going to drag this player object into prefabs. I've got player object prefab. I'm going to again go to assets. You notice they all go blue because it's a prefab now. Assets export package. Everything in the player export. And an appropriate location. Give it an appropriate name. Save. Separately, go to export. Apologies, I'm on the player assets export package. This time, deselect the player. Actually, I'm going to include the scene. We're going to rename the scene. So, scene, sample scene. Let me rename that. Name sandbox. Again, to export. Assets export package. I want the environment. I don't want the player. I do want the scene. It's going to want the player in that scene. I think. Let's see what that does. Export. Package 3D sandbox scene. Now let's test our new packages. So this is a blank project called test project. going to go assets, import package, custom package. Find the packages I've made. I've got package 3D character and package 3D sandbox scene. Let's start with the character. Get an import showing those pieces, import those. There has been added with materials, prefabs, prefab, and scripts. Nothing had changed my scene, no new scenes. I'm going to go to assets, import, custom package, and the sandbox scene. I'm going to import those. I've got a new one, materials, green, and a new scene. I double click on the sandbox scene. Now the player is in it, and that was my fault. I should have deleted the player before importing the scene, exporting the scene really, because I prefer the idea that if I delete that, because actually it's not even the object. I want a blank scene, so I can just grab my player prefab and drag it wherever I want to drag it to get started. That would be a better way to do it. So I might want to re-export my environment without a player object inside of it. Thank you very much. You may like to take a look at my other videos or subscribe to be notified of future content.